Hello friends, how are you doing today? So in this video we are going to talk about containerization and container orchestration platform. Okay, and we are going to talk about the important components in container orchestration platform. Okay, so before going to the topic in detail, I just want to let you guys know that understanding Kubernetes concept is not that simple. So you should have at least kind of hands-on experience on creating image, virtual machine, allocating right memory and CPU, also like configuring the port, network, etc. Otherwise it's hard to understand Kubernetes or OpenShift concept. Okay, keeping that aside, I'm going to explain this container orchestration platform concept in simple terms. Okay, let's start step by step. Okay, suppose if you want to deploy your application in a container orchestration platform like Kubernetes or OpenShift, first thing is you need to install the container orchestration platform. Okay, the two major container orchestration platform available in this world is Kubernetes and OpenShift. Okay, so the Kubernetes is plain vanilla container orchestration platform, and the OpenShift has a lot more features compared to Kubernetes. Okay, so let's go step by step. First, if you want to containerize your application, the first step that you need to do is install the container orchestration platform. So second step is, after installing container orchestration platform like Kubernetes and OpenShift, you can deploy your application in container form inside these two container orchestration platforms. Okay, so basically if you look at cloud infrastructure, there will be a provision for all your platforms, and after installing your platform you will deploy your software inside the platform or application inside the platform, so that your application will run fine, right? So basically it is infrastructure, then platform, and then software. So here in this topic we are going to talk about the platform area. Okay, basically the platform is a kind of source available for your application to run, right? So Kubernetes and Red Hat OpenShift are the platform components. Okay, so let's start with Kubernetes installation first, and then we'll talk about how to deploy the application inside the Kubernetes orchestration platform. Okay, so start with Kubernetes installation. You suppose if you are willing to play a soccer game, what you need first, you need a playground, right? You need a playground, and that playground should have marks and goalposts, etc., right? Similarly, if you want to install a Kubernetes orchestration platform, you need a right virtual machine. Okay, the virtual machine with the right configuration of memory, CPU, and storage area, right? Basically every Kubernetes orchestration platform needs at least 2 GB of memory and 2 CPU configurations. Okay, so let's assume that you got a virtual machine to install Kubernetes orchestration platform. Okay, and in case of soccer game, what happens, every soccer team has meaningful coaches, right? The coaches are key part of any soccer team. Similarly, in Kubernetes, the master node or admin node is considered as a coach for coaching all the worker nodes. Okay, so in soccer team there will not be only one coach, there are multiple coaches, right? Assistant coaches and special coaches. Similarly, in Kubernetes container orchestration platform, the master node has multiple components. Okay, the first component is API server. So as a soccer coach, you should have that capability to connect with your team members. Also, you should have the capability to talk to the external persons and other coaches, right? Similarly, the Kubernetes master node has a component called API server that has the ability to connect with worker nodes and other components of worker nodes, and also inside the master node. Okay, and the second component of master node is control manager. So in a soccer game, if a player is tired and he wants to come back, and new player has to go in and play for that the player who came out, right? Similarly, the control manager component has the ability or skill to find out which node is going down and who should be replaced with that node, right? So that information is available in the control manager component. And the third component is cloud control manager. Suppose if you want to deploy your application in your favorite cloud like AWS, Azure, IBM Cloud, or Google Cloud, and you should have a component to help that out, right? This is similar to a coach who has the contemporary techniques and knowledge to help the worker nodes to run fine in any cloud environment. Okay, so this being helped by this cloud control manager component. And the fourth component is etcd, or persistent storage. So as a coach, what you need to know about your team or your players, you need to know about the history of the matches, you need to know about the metrics of each player, and you need to know about the ground condition, all those stuffs, right? So similarly, the etcd component has all the metadata details about your cluster, and it stores all these values in key value pair, so that you can retrieve and view what is the metadata of the cluster. Okay, and the final component is scheduler. So basically, as a soccer coach, you should know when to introduce a person and which spot, right, in the ground. Similarly, this scheduler component has the ability to monitor this worker node and put in the worker node wherever needed, and if the worker node counts need to be increased, and then the scheduler will have the ability to increase. So basically, this master node is similar to a soccer coach for your soccer team, where this master node has all the assistant coaches like API server, control manager, cloud control manager, and etcd, or persistent storage, and the scheduler. So these are all similar to the additional coaches of your soccer team, helping the worker nodes, which are nothing but your soccer team players, to play well in the game. Okay, so let's move on to the worker node. So what is worker node? Worker node is a component where your application runs in the form of pod. So what exactly the pod? Pod is a collection of your container. So what exactly the container is? Container is your image with runtime. So what is your image? Image is nothing but your application. So worker node is nothing but your application that runs inside the container, and it's wrapped by the pod, and it will run on a worker node. Okay, so these worker nodes need to be taken care or controlled or managed by the master node. Okay, so you can spin up as many as worker nodes you want, depending upon your application capability or scalability purpose. Okay, and if you feel like your application is a very high volume application, and you may need to spin up additional worker nodes. And similar to spinning up additional worker nodes, you can spin up additional master nodes also to control your additional worker nodes. Okay, so this is how the master node and worker node combinations and their relationships are existing in Kubernetes cluster. Okay, suppose if you want to install these components, Kubernetes has multiple tools available. Okay, kubeadm is one of the tools, and if you install this tool in your virtual machine, all these component installation will be taken care. Okay, and this is optional only. you may or may not install these software tools available for installing your Kubernetes cluster, or you can install all these components manually one by one in a virtual machine and set up your Kubernetes cluster. Okay, so to summarize, assume that your Kubernetes cluster is a soccer playground where your master nodes are your soccer coaches, that includes main coach and assistant coaches, and your worker nodes are your soccer team players. Okay, so the worker nodes are controlled by the master node that runs inside the Kubernetes cluster. Okay, so hope you might have got an understanding of how Kubernetes cluster looks like, and what are all the main components like master node and worker node, and inside which what are all the main components of master node, like API server, control manager, cloud control manager, etcd, scheduler, etc. Okay, so hope you got some idea about this Kubernetes cluster and their components. And I wrote a clear article about this video and published in LinkedIn newsletter series. I have provided the link in the description below. You can go through and read and enjoy the content of this Kubernetes component installation and their roles in simple terms. And if you like this video, give a thumbs up and share this video to the friends, and so that they can also get benefit out of this video. Take care. Bye.